So the really interesting thing about rocks is that you can analyze all sorts of things about them to really tell the stories of what happened in the geological past. I'm Bob Gooday. I'm the Earth Systems Analyst at National Museum Scotland, and today we're going to be looking at this sample, which we hope records the meteorite impact that killed off the non-avian dinosaurs. This is a sample of marine clay that was formed during the Cretaceous-Paleogene boundary. The Cretaceous-Paleogene boundary, also known as the KT boundary, is the name that we give to the moment in time where the meteorite landed and caused the extinction of the non-avian dinosaurs. So this enormous meteorite landed in what is now Mexico and would have thrown up a huge amount of dust into the atmosphere. A lot of that dust would have contained the chemicals that were contained in that meteorite, for example, iridium, which we don't have much of on Earth. I don't think we'll be able to detect any of the iridium because it's such a small amount, but there should be other chemical traces like nickel and chromium that we would hope would be elevated in this rock. We're going to prepare it for analysis. The first step that we're going to be doing today is cutting the specimen on this specialised rock saw, which makes a very precise and very straight cut. So this is the sample that we cut on the saw, and it's now been cleaned and dried. And the next step is to embed the whole thing in resin, and that will give us something solid and smooth that we can then prepare for analysis. We've now embedded the specimen in resin and the resin's cured. So now the next thing to do is to polish it on finer and finer grades of sandpaper to get a really nice surface finish for the microscope. We're now starting to see much more internal detail inside the rock than we could see before we started preparing it. Yeah, I'm happy with that. Before we put the specimen in the microscope, the surface needs to be electrically conductive, so we need to coat it in a really thin layer of carbon using the carbon coater. So now we're going to put the sample into the Scanning Electron Microscope, and we're going to use an array of these different detectors to give us all sorts of information on the chemistry of the particles inside the clay. Oh, there we go. That's a little snail fossil. The snail itself is about 150 microns in size, which is, well, yeah, 100 microns is 1/10 of a millimeter. At the moment, I'm trying to find out the best places for chemical analysis. So you can see here we've got very definite peaks for zinc, nickel, and copper, which aren't the sort of metals you'd necessarily expect to see usually in these sorts of marine clays. Yeah, it's just this little blob. It's interesting. So what I'm going to do is I'm going to scan the beam across this area, and that'll show us information on the distribution of the different elements. At the moment of impact, huge, we don't really know how big, but probably kilometers across, meteorite, probably an asteroid, hit the Earth in what is now the area of the Gulf of Mexico, and that would have kicked up a huge amount of rock and dust and molten material up into the atmosphere, most of which would have landed back down in the area, but all the really fine particles would have made it up into the atmosphere, and over the next few years blocked out the sun, caused huge amount of climate catastrophe, and eventually would have settled back down on Earth, and a lot of that would have settled in the sea, which is why we can see the signature in marine sediments. So the really interesting thing about rocks is that you can analyse all sorts of things about them to really tell the stories of what happened in the geological past. We were doing some fieldwork recently up in the northwest of Scotland, looking at a site of a much older meteorite impact. Seeing the evidence that you were that close to such a huge impact event was actually quite scary. That was humbling. That was actually quite terrifying. So yeah, we can see that this bright layer is definitely rich in iron and nickel. We've definitely been able to detect some of these metallic elements like nickel, zinc and chromium, which definitely suggests that this sample of marine clay was affected by the fallout from this impact event. So that confirms that this specimen is from the Cretaceous-Paleogene boundary layer, which is the geological record of the event that killed the non-avian dinosaurs. Yeah, it's really great to be able to use analysis of this really tiny rock specimen to show evidence of the impact of this really massive global event.